Hello everyone, in this video I would like to briefly discuss how can we set up the Ethernet IP communication between the OMRON CJ2M CPU 3 series controller and this Ethernet IP device that is a MURR Impact 20 8-digit input, 8-digit output device. This device just used as an example. The main aim in this video, I will show how can we set up the Ethernet communication within this network configurator, this tool. OMRON within the CX1 is actual PLC programming software that is CX programmer. The CX programmer, especially for this CJ2M, that mainly program absolute address program, is a little bit old style. And when we build up the Ethernet IP communication, especially when we use this network configurator, we mainly set up the name-based connection. But inside the CX1, CX programmer, this software, we still use the absolute address. For example, at this CJ2M, the popular address we will use, that is a W, D, and H, these three typical type address. How can we set the absolute address within this network configurator? In this video, I will mainly discuss this. Okay, let's firstly connect this controller and let's set this CPU IP to 1.10, this IP address. And this Ethernet IP device, MURR device, it has an 8-digit input and 8-digit output. So I preset the IP address to this device, that is a 192.168.1.193. We will not mainly discuss this device. You can imagine in your case, you might have the wire bank or Ethernet IP device or the robot. All those Ethernet IP device are similar idea. I just use this device as an example. Okay, to connect and program this CJ2M CPU, we will use this CX programmer. When we install the CX1, this package software, you will install this CX programmer, this software. Okay, let's double click. So the first time when you try to connect this controller, we can go to PLC Auto Online and select one of this selection. For this CJ2M CPU 30, it has a built-in Ethernet port. So we can select this Ethernet IP not online. Keep in mind, this selection is just used for CP1 series. We are using the CJ2M, so we will select this Ethernet IP not online. So at here, we can select the USB connection or select this Ethernet IP connection. If this is the first time for you, you can click this browse. Let the system browse the controller you are connecting. So currently, you better directly connect this controller. Otherwise, if you connect this CPU in a network, so your software maybe browse a bunch of devices or IP addresses in this list. So you will be a little bit confused. Now, this software search this controller, this CPU. So my CPU, that is a CJ2M CPU 31. So I preset the IP address 1.10 here. I will show how can we set up the IP address after. Okay, let's select the CPU. Okay, so connect. Okay, the system pop up this. Do you wish to transfer program from the PLC after online automatic? So if this is a brand new controller, probably you can select no, because you can offline set up your PLC and then download all the configuration. Or if your CPU has something inside, you can select yes. So this time, this software will upload everything from this CPU. Okay, so it shows upload success. Okay, to set up this CPU IP address, we can go to I/O table and a unit setup. And this basic idea is a hardware configuration here. So we can click this CJ2M EIP, this port. And here we can set up your CPU IP address. If this is the first time for you to set up the IP address, by default here, that is 0. So we need to set something here. So I can set 192.168.1.10. Don't forget, set this subnet. For example, my subnet is 255.255.255.0. Okay, once you set up your IP address, keep in mind you need to click this transfer PC to unit. If you need to upload the configuration from your controller, from your CPU to your laptop, you can click this. Now I will click this transfer PC to unit, directly set this IP address. Okay, it shows processing cannot be done because of the CPU is running. Okay, because now this controller is in running mode. So we need to shift this CPU to program mode. Okay, select this program mode. Basically, once we select program mode, this CPU will shift to stop mode. Okay, and now let's go back. Okay, let's click this PC to unit. We will set the IP address to this CPU. And after this, we can click this compare. Let's select this compare to double check if this IP address set successfully. Okay, compare successful. That means currently our controller is running as this IP address 1.10. Okay, after this, we will go to the network configuration tool to set up the Ethernet IP connection. Before that, I will quickly show the memory address in this CPU. So let's double click this memory. Just a quickly review. From this OMRON PLC, for example, CJ2M, this is a series controller, the popular CPU memory address we will use, that is the W, H, and D. Basically, for data transfer, we mainly use the D. For the logic program, we will mainly use W address. For the data transfer, we will mainly use D. If you need to transfer the logic results to network, probably you can do a mapping from W to D. That's very easy. You can just use the move D or use the transfer block, that function block. Okay, so here I will use the D address. Okay, if we double click D address, we will see the D address has a huge memory range. Okay, but the W address, keep in mind, from the CJ2M, this series controller, that W address just from W000 to W510. So it's very limited. But D has a tons of room here. That's why usually for the communication or for other data processing, we will mainly use the D address or H address. Okay, so now let's shift to the network configuration tool. From the OMRON CX1, when you install this software, this network configurator will not create this icon at your desktop. You can search from this list here and drag this network configuration tool from this area. So by default, this network configuration tool will not create this icon. Okay, let's double click. So this network configuration tool is a specific tool to set up the Ethernet IP communication between the OMRON controller with other controllers or OMRON controller to OMRON controllers. Okay, so in this test, my CPU IP address is 192.168.1.10, and this MURR address, that's 192.68.1.193. Okay, and before we set up the Ethernet IP communication, we need to download the EDS file from MURR website to set up the Ethernet IP communication configuration. Then we can browse the MURR website and search this article number. That device has an 8 input and 8 output. And from this download here, I can download this configuration file. It has an EDS file. Also, I can download the menu from here. Okay, after we download the EDS file, after I unzip, that file is named this. So we need to install this EDS file inside this network configurator tool. Okay, so firstly, let's install this tool. Select this EDS file, select this install, and browse the folder. Okay, browse this folder, and we will find this EDS file. Select open, select install. Okay, after we install, we will see this MURR folder, this impact 20, 8 input, 8 output here. From this network is a graph view, very easy to understand. So let's firstly drag our controller from this OMRON. So let's find out the CJ2M here. Drag this EIP 21. Okay. A named EIP 21, and then let's drag this. Okay, so that's the MURR block. Okay, let's firstly change this IP address. Select this change node address. Our CPU, that is the 1.10. And this block, select this change node address. So this MURR block, that is a 1.193. Okay, we set this IP address. And then to set up this communication, so we can drag this device on the top of this controller and release. So it will pop up this connection wheel. So that is very easy for us to understand this data direction. For example, here, that means this is the data flow from this block to this controller, and this is the data flow from this controller to this block. And here it shows input 100 and output 112. That is the assembly number. This assembly number, that's the one terminology from the Ethernet IP communication. If now we quickly browse this device, MURR device, okay, I use the web browser, type in this IP address 192.168.1.193. That is this MURR device. So at this home page, we'll see this. This I'm going to show. So this assembly instant input 100. That is the data flow from this block to the CPU. And this assembly instant output, that is data flow from the CPU to this block. That is 112 here. That is the 112 here. And this assembly instant configuration, that is the 128. But fortunately, this device gives us the EDS file, so we do not need to manually set this. But some cases, if you are using the robot or some other devices, in some cases, their EDS file just have a connection, the basic information inside. You have to manually configure the input or output assembling this number. Keep in mind, usually we need to reverse, connect your PLC input to the device side output and connect your PLC output to the device input. You need to reverse this direction and the assembly number. Okay, let's shift back to that configuration tool. This file comes from the EDS file we just installed here. So that file already built in, already configured this input assembly instant and this output. Now, let's set up this data flow from the device to the CPU. So let's click this edit tag site. So this window is a specific place to set up the data flow, how many bytes we need to transfer from this device to the CPU. Let's click this edit tags. Okay, and keep in mind here, that's the consume. Consume means this is the PLC reading the data from other device. So that means the consume in. That stands from the CPU side. Okay, keep in mind this data flow direction. So now we click the new. Let's set up the name. And before we set up the name here, let's review. Since this assembly instant input 100, that is the data flow from this device to the CPU. Its length is 3 bytes here. So we need to set something to match this size. Go back. So here, firstly, this size is 3. And the name is very important to allow our CPU to read the data from this network. Our controller will mainly use the D address, the H address, or W address. So here I will use the D address. So here I will type in D100. That means we will start from the D100 and we will transfer 3 bytes. Okay, let's click this register. Okay, the reason why it has 3 bytes rather than just 1 byte, that because we have the quality data behind to show the input signal diagnose information. So that's why it has 3 bytes here. Okay, so we can click OK. So it will show the new tags will be registered. Okay, here. So here, keep in mind, we have a same name here, but the actual working tag name, that is this. If you are going to change the address, so you need to click here and click this edit. For example, if we added here, for example, if I add it to 102, if I click OK, so you will see the original name, that's the 100. And now we change to 102. So which actual address is working for the communication? The answer is this. This is the edit tag. The edit tag actually is working for this line rather than this line. The first time when we set up this connection, they are using the same. But in case you have to change this address, so once you change, keep in mind, you have to select this edit tags here. To match the name, you can click this line and click this edit. So here, this area is really confused, but this area is just a name only. The actual working for the communication is this line. Okay, so if now I change to 102, so I can change to 102. So we'll change the same name here. Okay, to easily demonstrate, I will change back to 100. So for this line, we will click this edit tags. That is the actual working tag. Okay, so for change this line is just a group name. Okay, basically we will match this name to prevent the confuse. Okay, so we match this name, click OK. After we create, so we create this D100 by clicking this. So once we click OK, now we can select here. So we will see this data flow, this 3 bytes from this device to this CPU. So here we can select the multiple cast or the point-to-point. Okay, for the efficiency, we will select this point-to-point. Okay, and for this line, output from the CPU to this device, here, that is the 1 byte. Okay, let's click this edit tag set. Same thing, click this edit tags. Click the new. And now I can select D200. So this D200 will set the value from our CPU to this device. Okay, default here is select the 2 bytes. We need to manually change to 1. Let me show one thing. So if I forgot something here, I select 2 bytes and register. Okay, we register 2 bytes, click OK. And we set this 2 bytes here. Okay, select OK. After we select, we will see. So here, that is 2 byte, but our actual data from this device is receiving 1 byte. If I select here, if I click the register, it will show the wrong I/O size. Okay, because it doesn't match. So now we need to click this edit tag size. Go back. Click this edit tag. Click this edit. Change this 1 byte. Okay. From this tool, the complaint here, so it has a multiple edit new and edit tags. Keep in mind, so this line by using these buttons, but for the actual data is using this edit tags, 1 byte. Okay, now we change back to the 1 byte, makes it correct. So now that is 1 byte. Okay, so the data from the device to the CPU, that's 3 bytes. And the data we set from our CPU logic to the block, that is 1 byte. Okay, let's click this register. So now that connection has been built up. Okay, after we set up that connection, we will see this icon here. That means this device is connecting something. If we double click this device, we will see that is the actual input assembly, output assembly, and configuration size. Okay, that actually need to match the web page showing from this device 310. Okay, because we install that EDS file, so that's all come from the default. Okay? And if we double click here, so here is showing the configuration we just set up. Okay, if we click this edit, we can go back and edit this. For example, let's click here and we can go back and edit or change the address. Okay, for example, here we can change it something here. And keep in mind here, this ID here it shows auto. Okay, if we double click here, And if we click this advanced, so this number, that actual number, that means this. Go back from here. This assembly instant input, that 100, that means here. If we don't have the EDS file, we have to manually set up this number, 100. And for the output data from the PLC to this device, we need to set up the 112. Keep in mind. Now, because we are using the EDS file, we can select this auto. Okay, if we double click this CPU icon, it allows us to quickly reveal the setting behind. Okay, click OK. And now we can download this connection to the device. Firstly, we need to set up the connection from this tool to the controller. So first select this option, select the interface, and select the Ethernet port. So this tells this software using which way to connect the controller, connect the CPU. Okay. And now let's click this button, connect. Okay, it will browse if we double click here. So it found this controller. Okay, and this name match our configuration here. And let's select back and click OK. Use the existing network. Okay, once we click this online and once it shows blue, that means this software finds this controller here. We can right click this monitor. It's showing the status. Okay, now we can download this connection. We will download this configuration to all the devices. So we will select this, download to network. Okay, select yes. So it will download those configuration to this controller. Okay, click complete and select this device. Let's download to device. Okay, download to device. So this basically download again. Okay, don't forget download. Okay, after the download, we can right click this monitor and see the status. Click this connection. So it shows currently this CPU connecting this device 1.193. That means it's correct. Okay, now we can go back to the CX programmer and let's test the actual data. Okay, now we come back to test the data. So let's go to the memory and let's go to the D100, that is receiving the data from that device. If I type in 100, so it will directly jump here. And here, let's select this binary style. So this 100, so we are using this binary style. So we can look at the individual bit. Okay, that address receiving the data from that block to this CPU, that is 100. So we can watch here. Okay. Now we can click this monitor. So it's monitor the actual data here. So I'm jumping the third input. So that's showing 1. If now I disconnect that input, we will see the data. Off, on, off, on. Okay. Okay. I'm connecting the number 8 input. So that is the number 7. It starts from 0. That is the number 7. Now it's showing on. Because it has an 8 digital input. So the data from 0 to 7 here. Okay, now if I'm going to program a very simple logic, for example, do a simple mapping here. So let's shift to the offline mode. Okay, I will create insert above, and let's create a very simple logic. Click this. Let's go to the date move and select this move. This is a very simple move. Okay, let's select OK. Okay, and this source, okay, the first area, that's the D100. That's the D100. That is receiving from the 8-digit input. And next area, we will map into W address. For example, W address is 100 also. Okay. And now if I download, compile and download, connect this controller, and let's transfer to PLC. Okay, transfer. Here, that 128, that is a decimal style. If I shift to the 16 hex style, it shows A0. So if we go back here, click this memory, and here if we click this monitor, and if we shift to the 16, so we'll see that D100, that's the A0. If we shift to the byte mode, so here we'll see the number 7, this bit, that is 1. Okay, our CPU is still the program mode. We haven't shifted to run mode yet. The reason why this data buffer it shows 80, that because the communication is running behind, but the CPU, the logic wise, is still in the stop mode. This logic wise haven't worked yet. So once we shift to this CPU to run mode, so we'll see it immediately run the data from this D100 to W100. So this is the typical way transfer from a network interface to an internal logic wise. So this W address 100, we can use the individual bit and for our logic. Okay, let's test the output from our CPU logic to the device. Okay, this time I will show how to do the online change. So first let's shift to the monitor mode. Okay, the monitor mode, the CPU is still running, but that allows us to online set the data or do the online modification. Okay, so let's click this begin online edit. And from here, let's click insert below. We insert one line. We'll use the similar logic here, first line. So same. And here, this time, the source data, we will write W200. And the target data will change to D200. Okay, that means we will set something from our W address. Using this move, we will transfer this W200, this one word, to this D200, this one word. Okay, and after this, let's click this, send this change. So now the CPU is running this logic. Now, if I double click and let's write the data here. For example, let's write 128. So this will write this, the highest bit, that bit 7. That is the number 8, the output. So if we go to the memory, here we will see the W200 transfer D200. And here, if we go to browse the D200, this address, here we will see this bit turn on. And now, and because this is output data from this menu here, so this number 4, that represents the highest bit. So now this number 4 is turning on. If I'm going to turn this on, that bit 03, so we will turn on this bit. If now I'm going to turn this on, that decimal, that is a number 8, the 8 decimal. So here, go back to the W200. If I change to the number 8 decimal data, okay, and now if I go back to the memory, we'll see this bit 3 that turn on. Okay, so actually now this bit, this output 03 is on. Alright, this is a very brief Ethernet IP connection test. So in this test, we are using the CJ2M, the CPU, the CJ2M CPU 31, this controller. It has a built-in Ethernet IP port. And my testing device, I'm using the MURR, this 8-digit input, 8-digit output, and its IP address is 1.193. To set up the Ethernet IP configuration, we use this network configurator here. And firstly, we install the EDS file, and then we drag this icon on the top of this CPU. So, and then the system pop up the connection wizard and guide us. We set this D100 as a data receiving the data, and also send this D200 from this CPU to this device. That 8 bits. Okay, and then we use this logic to demonstrate receiving the data from this D100, and then we transfer the W100. In the logic, we can use this W address to do our logic. And if our logic has some result and transfer the individual bit to the W address, and using this move W200, we transfer this W200 to D200, and using the Ethernet IP, transfer this D200 to that digital 8 output to that MURR device. So this is the typical Ethernet IP connection setup and the logic processing. Alright, that's it for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.